in their graphical componentry. So when you guys are trying to graph this data to get a look at it, when you guys are trying to graph this data to get a look at it, and you go to second y equals, make a note of what things are off and on. Very often, we'll have one or two different things on, and you might not always want all of that stuff on. For example, right now, who's simply making a histogram? So you probably just want L1 on. Is anybody doing a histogram with a box plot? Nobody's doing that yet. We'll do that too. But we get it. But so you ask yourself, how many graphs do you want? Make sure only those graphs are turned on. Otherwise, you're going to get goofy windows that have strange data in them and you don't want. So let's just go with just the histogram for starters.
Sure.
So plot 1, let's turn it on. Make the type be a histogram. Yes? Good so far? This is wrong though, yes?
Yes.
Because I don't want L11, I want L1, L2. I got to make sure I have L1, L2. Why is it important to have L1, L2 right now?
Because you're frequency.
Can I change your statement a smidge, Haley?
Yeah.
You have data and
The
frequencies. Yeah, and that's, I'm being nitpicky on this one, Haley, and you can tell, it's okay, just tell me to shut up.
No, you're
but
fine.
data is really the only thing you're analyzing. What did I ask you to estimate?
Your height.
My height. I never asked you to estimate how frequently each of you would say those heights. So the frequencies, if you will, are kind of like dependent variables.
Okay.
Right? So the only data that we're looking at is the actual height estimates you gave me. Is that fair? Is that fair? Are we good? We good? Okay, good. So now I want to go with the zoom 9. Oops, too many buttons there. Here's the graph I get. With your permission, I'd like to knock it down so it's a dot plot, which means everything's got a width of 1, because it looks like we got a width of like maybe 1.5 or something like that. I'm going to go to window 1.8. Let's finagle. I'm just going to change, for starters, I'm going to change the X scale to 1. For starters, that's okay with you guys?
Yeah.
And then press graph. There we go. Look at this. Now this does not surprise me at all. This pleasantly surprises me. That has never happened with this experiment before, which I love. Have I ever mentioned my height in this class before?
No.
Good! How about my weight? Good! Okay, we'll get to that, we'll get to that too. Did I mention it once? I may have, maybe.
You only said you were overweight once.
Well, I've referred to the fact that I'm overweight constantly. I never told you what that weight was, did I? Good.
What is it?
Well, we'll figure that out next. No, it won't be. So let's figure out, of these estimates that you guys provided me, would you call, it almost looks what?
Skewed.
I would call this very skewed because of that crazy right tail. So now I have a question for you. Of those values, are any of them outlier worthy? Would any of them be considered outliers? No. In other words, too extreme. A couple people saying no, because we said them. How can they be outliers if we said them, right? Good, very good, very good, very good. Please, Riley, go.
No, because it's like, it's skewed, but it's not like, it's only one thing away from everything.
What's a thing? What's one thing? Oh, in other words, there's a gap right here.
Yeah.
There's a gap here. One gap isn't enough. You've given me what's called a metric for measuring outliers. So you say one gap isn't that bad. If there were 2 gaps, then I'd be like, okay, that'd be an outlier. Maybe. You see what Riley just did? She gave what's called a metric. She gave a unit to measure something with. Good. Nobody actually uses that one. But that does not mean it's not a metric, and that does not mean that I'm not stoked to hear it, because that means you're thinking along the right lines of how to metric unusuality. Thank you, sister. Go, Taryn.
I would say it's not an outlier because there's not enough data. If there was more like 1070 votes or like 2070 votes.
Okay. So what you're doing, okay, would everybody please do this? Add a column, not in your TI, but on the board. Let's add a column for percentage occurrence of what you said. Let's do it by percentages too, okay? Just to kind of get this idea planted in your head. Turn the TIs off for a second. We'll come back to it. We'll come back to these. But what we're going to do, let's put a column over here called percentage. And let's see, okay, so 2 of you said I was 68 inches. What percent of the class, therefore, said that? Let's do it that way, right? So we got 2, 4 is 6. 11, 15.
19. 20. 20.
Well, that just makes my life so happy. 20 is so easy to divide to. Every one of you is 5% of the data set. My happy dance. So, what percent said 2?
10.
Exactly 10. How about 4?
20.
Good. 5?
5.
freaking nice.
Five.
Yes.
Five.
Oh, yeah.
Five.
I'm gonna need 0, I guess, technically, right?
Yeah,
Some of the zeros. So, is this what you're getting at, Taryn? Ish?
I think.
Maybe. I like what Taryn is saying is she's looking at the curve and seeing the hump of data. That's where the majority of the hump is. But her claim is that the hump isn't humped enough because it's not tall enough. Now, we could be bad statisticians and make it look bigger by simply scaling the axes different. Right? I can do that. Watch. There, it's bigger now.
Yeah, but now the ones are bigger too.
Ah, yes, yeah, proportionally, because I was a good statistician by making everything proportionally larger. Good for you, sister. But I don't want to. The reason I bring this up, Taryn, is you actually jumped to the one I usually talk about last because it usually shows up last in discussion. But one way of measuring outliers in data sets, and it works better for large data sets than small ones. But here's outlier ID methods. Outlier ID. I'm going to call them metrics. You know what? Because you guys need to learn that term in context. A metric is anything. When you hear the word metric, what do you think of?
Measurement.
The metric
Measurement.
system, right? You look at the metric system. The reason it's called the metric system is why?
They use a meter.
Because it's used to measure things. Every system is technically a metric system because it's used to make measurements on something. For some reason, the one that's based in Towers of 10 got called the metric system. I don't know why, it just did. It's also called the SI, right? The Standard International.
Yeah.
I believe, if that French translation was correct. But it's the default system on the planet for measuring things. Only a couple countries use feet and inches and pounds. Us, even the English don't use the thing that's called the English system. It's amazing. So when you metric something, you measure it.
Right.
So how do we metric outliers? Well, one way is to look at what's called the relative frequency or percentage occurrence. So this is one way of doing it. Look at the percentage occurrence of the data. Look at the percentage occurrence of the data. And say to yourself, okay, I need a number now, where if the data doesn't occur frequently enough, the reason I like this so much is because it ties back to one thing you guys said. Who told me it doesn't occur as frequently as typical data? Was that you, Alicia? It ties to that. So, define frequently enough. What is frequently enough as a percentage? How much would it have to occur in order to be frequent enough, do you think? Over 50%. Well, unfortunately, that means everything's an outlier in our data set. Because nothing occurred 50% of the time, right? Does that make sense?
Yeah.
Good?
Would it be more than the lowest point?
Okay.
So like you have a bunch that are tied at 5%,
Yes.
but then we have one that's double that.
Okay. Hold that thought. I love that. So, Taryn brought up a very good point, too. This is a very, very small data set, yes? Exceptionally small data set. Because it's an exceptionally small data set, it's got high volatility. If I was to add 5 more data points, these things could change and in a big way. In a big way. If I double the data set, obviously it would cut all the percentages in half. Riley, go ahead. What's on your mind over there? Are you sure? Sure. Okay. So, the default, and this is just getting you guys ready for your psych majors, your SOS majors, your HCFS majors, your medical majors. I'm sure this is in the medical research as well. The default percentage for ID, outlier ID is 5%. Anything that happens 5% or less of the time is termed an outlier. That is by default. I'm not saying it's always the right answer, but I'm saying that is the default identification mechanism. So Riley, or no, Alicia, I like what you said about how 5% is half of 10, which is half of 20.
Well, I said it's like the lowest percentage occurrence.
In that data set, right? Good. Now the problem is, the lowest percentage of data set in a data set might be 15%. But that doesn't make it an outlier necessarily because it still happens 15% of the time, which by statistical measures is quite a bit. That's 3 out of every 20. The cutoff that is often used, and we will discuss this at length in 244, is when 5% is too small or too big. Because sometimes it's not. I don't want to worry about that right now. Not right now, because we have to do more detailed margin. I'll do it because we've got the whole 244 thing. 5%. So one way of looking at occurrence, if any data occur less than 5% of the time, call them, to use your word, Alicia, atypical. Now we can get into a fist fight all day long about strictly less than or equal to, can't we, Corey? We can get in a fist fight all day long. Sorry, man. We'll interrupt that. he was, it's all good. We can get in a fist fight about this, right? Because these all came, a bunch of them came in at 5%. Does that mean they're all unusual?
No, because they're not less than.
Exactly. We can get in a fist fight about that. What if it's less than or equal to 5%? Does that mean they're all out? Exactly, right? Audra's like, no, I don't think so. Good for you. Because my point of fact is that as this data set gets larger, they will not all be 5%. I predict, anecdotally, based on past evidence, that if I was to ask 20 more people this same result, I would not get the exact same results again. I've never been called 6 feet, or whatever this is, 6'3". I've never once, with my hair down, been called 6'3". Ever. That's a first. What's that?
How tall are you?
I am, let's see, did you catch me on average? I am just about here.
Yay.
I'm 5'11" and a half. I've never been 6 feet. Not even first thing in the morning when gravity's on my side. When I'm laying flat all day, all night, and I get up, I'm still not 6 feet. I'm just this much under, no matter how tall I am. So you guys actually underestimate my height quite a bit. And that's what I want to do next. I want to crunch the measures of center on which your guesses are and see where they fall, yes? But yeah, 5'11" and a half is what I tell people. Not quite 6, they never quite got to 6. Cool? Cool so far? But before we get into that, I don't want to get into that just now. What Taryn just said is wonderful because it ties to this atypicality. So one way of looking at data is to look at a percentage occurrence of it and say, okay, typical happens more than 5% of the time. Now, another way you could look at that is, well, the most extreme, oh, this is 6'5", isn't it? Excuse me, 6'3" or 6'5". I've never been called either of those things. 6'5", bless you. 6'5" would be here. That's just amazing, right?
It's like a bun on top of your bun.
That's right, it's like bun. Like, were you guys around last year during the math contest we ran when I had my hair at Liberty Spikes? I was like 8'2" that day. I had my hair stuck up with glue. It was fun. Anyway, so this right here, this max point, is 5% of the data. Everything else other than that max point is the other 95% of the data. That's one way of looking at it too. So you could class it like that and say the most extreme data point is separated by the gap that Riley has there. And I mean, I'm not going to write this down as a metric because it's too hard to metric, but one way is just to look at the data and say there is a break from 6'3" to 6'5", therefore 6'5" is way too big. That's totally fine. You can say that. Good luck getting it published. It won't get published without some kind of metric attached to it. Is that fair? Is that fair? Why do you drive on the right side of the road?
Because the system told me to.
Because, well, I was going to think more, because if you don't, you're going to get into an accident. Because we have been trained that we drive on the right side of the road. Why do we do that?
To be safe.
I don't know why we do that, honestly. Why not the left side? I don't know why it's not the left side of the road. But we drive on the right side of the road because that's what we've done, right? I'm sure it's based on something
Because it's the right side.
British,
No.
I'm guessing. I don't know.
In Japan, they drive the other way.
They do, and in England they do as well, right?
Yeah.
Right. So why do we drive on the right side of the road? Because that is the standard that has been set up.
Because we use
Yeah.
feet.
And because we use feet and inches. There's a very interesting thing. Why is a railroad track the width that it is? Or why is the space shuttle the size that it is? And believe it or not, the reason a space shuttle, well, they don't fly them anymore, but the reason they were as big as they were is directly tied to the size of a horse's butt. Directly tied. If you follow the path of transportation from a Roman chariot to the railroads that carry a space shuttle, they're all interrelated back to the roads in Rome and the size of the chariots. And believe it or not, it's all tied historically back. So when I ask you the question, why do you drive on the right side of the road? It's not to create an issue about like the system and why it's right or wrong. Because that's what we do. And there are certain metrics that we use, and this is just one of them.
Why do we use 12s as is dozens?
Some dude's foot
Yeah.
got broken up into 12 instead of 10. I don't know, Silviano. Don't get me started on that one
The
either.
same reason we call it soccer.
Easy.
Yeah.
Easy.
Easy.
Time out. Easy. I don't want to get a fist fight. But the point is that we have certain conventions, and hopefully you've learned in this class that we can talk about the conventions, and you can take the conventions into the world, and that way the conventions you bring to the world, and you can have discussions and not have to worry about the definitions of the conventions. You know what the conventions are. That makes sense? Good. So that's one way of measuring an outlier.
What's the other way?
Well, there's a couple other ways. I want to ask you guys, though, can you think of another way? You guys asked me before,